So we're given sine beta is equal to 1 over 3, where beta is an element of 90 and 270. Okay, that's the information that we are given. And we are told that without using a calculator, determine the following, which is cos beta. So it's basically the value of the following, which is cos beta. Now, this information is very important. Okay, we're told that sine beta is 1 over 3, beta is an element of 90 and 270. Alright, so we have something which we call our Cartesian plane. I'll just draw it over here. So our Cartesian plane goes from 0 degrees to 90 degrees to 180 degrees to 270 degrees and then back to 360 degrees. Okay, so we have our 4 quadrants over here. So all trig ratios are positive in the first quadrant. Only sine is positive in the second quadrant. Only tan is positive in the third quadrant, and only cos is positive in the fourth quadrant. Okay. Now we are told that beta, which is basically an angle, lies between 90 and 270, which means it's in between the second quadrant and the third quadrant, because 90 all the way to 270 over here. So it lies between these two. Now remember what I said. I said all trig ratios are positive in the first quadrant, sine is positive in the second quadrant, tan is positive in the third quadrant, and cos is positive here. Okay. Now over here we are given sine beta is equal to 1 over 3. And this value is actually positive, right? Remember, we are told that it lies between 90 and 270, which is in between these two quadrants. And sine is only positive in the second quadrant, in between these two. Which means, when drawing your triangle, because you're going to need your triangle, which will help you. So let's draw it on this side. So again, 0, 90, 180, 270, 360. Okay, so remember we said our triangle lies in the second quadrant. So our beta is over here, and then we have 90 here. Okay, now we should remember our trig ratios. We have our SOHCAHTOA, so sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and then tan is opposite over adjacent. Okay, now this is going to be helpful. Okay, now remember we are looking for cos beta. We are given sine beta. So sine, remember we said it's opposite over hypotenuse. So opposite to beta, we have 1, and the hypotenuse is positive 3. Now we need to find this x value over here, what the value of that is. So we're going to use what we call our Pythagoras theorem, because this is a right angle triangle. Okay, so then again, x squared plus y squared is equal to r squared. X squared, which is our unknown, plus our y squared is 1, so it's 1 all squared. Our r all squared is 3, okay, squared. X squared is equal to 3 squared minus 1 squared. X squared is equal to 9 minus 1. X squared is equal to 8. And then the square roots of that. So x is equal to plus minus 2 root 2. So x is plus or minus 2 root 2. But in this case, when looking at this Cartesian plane, it's lying on the negative side. Okay, so all values of x on this side are positive, all values of y are positive going up. All values of x going this side are negative, all values of y going this side are negative. So which means over here, x is basically negative 2 root 2. So you indicate that on your diagram, negative 2 root 2. You're getting closer to the answer now. We're trying to find the value of cos beta. And remember we said cos is adjacent over hypotenuse, okay? So cos beta, adjacent to beta, which is what we're looking for, it's negative 2 root 2, and the hypotenuse is positive 3. So the value of this cos beta is negative 2 root 2, all of that divided by 3. Okay, so now we're looking for the value of sine 2 beta, and this is what we call our double angle, okay? Now let's just simply expand this double angle, okay? So when this is expanded, it's basically 2 sine beta times cos beta, okay? So it's 2 multiplied by sine beta, we are given that it's 1 over 3. And from our previous example, we saw that cos beta is negative 2 root 2 divided by 3. Now let's multiply all of the numerators. So 2, this is 2 divided by 1. So it's 2 times 1 times negative 2 root 2. It's going to be negative 4 root 2. All of that divided by 1 times 3 times 3, that is 9. And then you're done. Okay, so now we're asked to determine the value of cos of 450 minus beta, again for 3 marks, okay? So we're going to need our 2 diagrams for explanation. Okay, so we have our cast diagram where we said all trig ratios are positive in the first quadrant, sine is positive in the second quadrant, tan is positive in the third quadrant, and cos is positive in the fourth quadrant. Okay, so we said it starts from 0 to 90 to 180 to 270 and then back to 360. Okay, and then our diagram was something like this. It was in the second quadrant. I hope you guys can see this properly. So we had beta, we had 1, we had 3, we then had negative 2 root 2. Okay, this was our triangle over here. Now let's solve this over here. So we have cos of 450 minus beta. Now I strongly recommend, to make things simpler for you, whenever you're given an angle which is above 360 degrees, you must first subtract 360. Let me say that again. Whenever you're given an angle which is above 360 degrees, you go to that compound angle and subtract 360 degrees and then minus this beta, okay? And when you are given an angle which is below 0 degrees or which is negative, you should add 360. When it's above 360, you subtract 360. When it's below 0, you add 360. Okay, so this is going to be cos of 450 minus 360, that is 90. Excuse me, minus beta. Okay, you close the brackets. Now we have a much more simpler compound angle. So 90 minus beta lies in the first quadrant. Okay, look at this properly. 90, you subtract beta, you land in the first quadrant. And all trig ratios are positive in the first quadrant. Now what you should take into consideration is you are given 90. Whenever you're given 90 degrees or 270 degrees, you should always take into consideration that these two angles, they actually have an ability to change this trig ratio from cos to sine when you are reducing. So it's sine beta. And whenever you're given sine, you can change it to cos when you're given 90 or 270. So you have sine beta, and then finally remember we were told that sine beta is basically 1 over 3. So you can see that we're actually doing all of this without using a calculator. So we're given cos of A minus B is equal to cos A, cos B plus sine A, sine B. And then we're told to use the above identity to deduce that sine A minus B is equal to sine A cos B minus cos A sine B. So we're basically using this identity to prove this identity. Okay, we're going to use this to our advantage to prove that this identity is true. So we are given sine of A minus B. Okay, now let's use its co-ratio. So it's going to be cos square brackets of 90 minus A minus B. Let's look at this properly. This 90 minus A minus B, and including this cos, if you simplify this, it goes back to this one. How? This 90 changes this cos to sine, this A minus B remains. Okay, so this is basically that in a different form. Okay, from there we can then say cos of, let's rearrange this so it can help us in answering the question. So we can then say 90 minus A, group that, minus, in its own brackets, this negative B. It's still the same thing, it's just written in a different form, okay? And then from here, what we can do is, we can see that this looks something like that, which can help us in answering the question. So in this case, we have cos of 90 minus A minus negative beta. Let's let 90 minus A be our A. Let's let this negative B be our B. Okay? So let's now expand this to look like that, but using these angles over here. So we have cos A, our A in this case is cos of 90 minus A multiplied by cos B, our B in this case is negative B, plus, okay, sine A, our A in this case is 90 minus A multiplied by our sine B, in this case it is negative B. Now from here we're going to use our Cartesian plane. You don't need to write this down and answering the question, it's just for explanation. So we have all trig ratios positive in the first quadrant, sine is positive in the second quadrant, tan is positive in the third quadrant, and cos is positive in the fourth quadrant. So it's 0, 90, 180, 270, and then back to 360. Okay, now let us answer the question. So we have cos of 90 minus A. 90 minus A, that lies in the first quadrant, and all trig ratios are positive in the first quadrant. So this 90 changes this cos to sine, and it's going to be a positive sine A, because all trig ratios are positive in the first quadrant, multiplied by cos of negative B. Whenever you're given a negative angle, you should try to add 360 first to make things simple for you, and then plus sine of 90 minus A. 90 minus A is in the first quadrant, so this 90 changes sine to cos, and then positive cos A, multiplied by sine of negative B plus 360. So sine A times cos of, let's rearrange this to look normal, so 360 minus B plus cos A times sine of 360 minus B. Alright, then this is going to be sine A again multiplied by 360 minus B lies in the fourth quadrant, and only cos is positive there. We are also given cos, so it's a positive cos B, okay, plus cos A, sine 360 minus B. 360 minus B is in the fourth quadrant, only cos is positive there. We have sine here, so it's going to be negative sine B. And then it's going to be sine A cos B. Let's take this negative across to the positive sign and multiply it. And then minus cos A sine b. This looks exactly the same as that. So we have proven this, that the sine a minus b is equal to that. And we are done.